So I'm glad we are partner of the month, and to share with you some few information about ISL. We'll do the presentation with Nicolas. Actually, we'll do a short first presentation of ISL in itself, and then Nicolas will speak a bit about DigueELITE project he has been involved into, and then I'll finish with a special case study from on which I've been working for a couple of months now, and we will try to reach 5 minutes for each topic, so we try to finish at 30. So general presentation of ISL. So ISL has been founded in 1986, so it's been almost 35 years now that it's the adventure started. It was 3 persons at the beginning. The I, S, and L are the first letter from their names, so it came here. It's still 100% employed owned, so we are owning our company, which is very nice and allow us to do the way we like to do our work, so that is very nice. And our main markets and topics are around the flood protections, dams, water resource and regulation. Also, all that is about rivers and aquatic environments. We also deal with hydroelectricity and new energies. We work on different new energies. We have a specific also teams working on the sea and coast and harbor and navigation canal that are a bit more linked. And we also have people working on very specific infrastructure and more complicated like concrete structures. And we passed through the COVID years with the same increase in size and same income. So for us, it was COVID was not a big deal. So that's very nice. How we organized? We have 5 main offices all around France that are in more dark green, in Paris, Lyon, Montpellier, Saint-Jean-de-Luz, and Angers. And also we have some kind of satellites with smaller offices with smaller teams in the light green spot. And one you know is Lille, where I'm speaking from. And we are working on the market I talked to you about before, but almost everybody is working on all the different topics, and depending on the subject, we have some experts on some specific topics, but usually we work on most of topics. And for example, for Lille, we are working on some of the topics, but for example, not much on dam and water resource, since there is not so many dams here, and Lyon is much more working on dams, for example. So we split the work depending on the area also. Also, we have subsidiaries. We have technical subsidiaries. We have 3 ones that are working on turbines for BCN hydro, and this one is set up in Spain. WPI is specialized in hydromechanical and is in France. And you already know about DNNT, in which Nicolas is working, specialized in maritime and naval. Our in details, what we are doing is engineering, so design, planning, and we do the owner's assistant for construction follow-up, and we provide studies, so from feasibility studies up to very detailed studies in all these technical markets I have been detailed before. Few pictures just for you to have an overview on our topics. So some dams that has been built under ISL supervision, mostly in Africa, and some dams rehabilitation that has been done. One here is in France, but the other are in Africa as well. So very different kind of dams. This is hydropower topics. So all these are what we are very proud of, but in Lille we mostly work in navigation structures, so on locks, on canals, and you are aware about the canals in North Europe. That is ongoing right now, and we are pretty much busy with this topic. I let you the slide, and then you can also go on the YouTube link here, where you see a beam model of the canal and see what we can do with beam, also just showing structures and the environment of the structure is very nice. And we do some sea and shore structures, so just sea and shore management program, but also rehabilitation of structure and building new ones. And I'll speak a bit more about this Calais door afterwards. So we have been involved in innovation from the beginning. We try to continue this and spend some income on it. And it has been started with Michel, with the L from ISL, and is involved in a lot of international groups, working groups, and mostly the ICOLD and the French COLD. Also, Luc, who is our current president, is involved in a lot of technical working group, and that allow us to be aware about what's going on and to improve our way of designing and our technical level. I'll let the floor to Nicolas to go to a transition to DigueELITE projects.
Yeah, thank you, Cédrine. So as you said, ISL is from long time already involved in R&D projects alone or with partners. It's always in its core business, so in dams and hydraulic works, including levees. And sometimes we do some efforts alone, but we like to work with partners also, with or without external funding. Since 2009, we put efforts on levee and dam erosion processes, and it started in 2009 then with a French large-scale research program on internal erosion. So the idea there was to better understand the internal erosion process, but also to provide operational methods for engineers to assess the risk of internal erosion and to design levees and dams accordingly. And afterwards, we went to the next project. You can go to the next slide, which is the DigueELITE project. Yes, you can go to the next also. DigueELITE projects focus more on external erosion. So this program started in 2013. And it's, let's say, a comprehensive R&D program led by ISL on the use of lime-treated soils in levees and dams. So we had laboratory studies, engineering, we made an experimental dike, and we did we performed in situ real scale tests. So you see the partners below, and some pictures of the test site. You can go to the next. Here's a small video. I hope it will work. You can maybe go on sound.
Sorry?
The sound lower. Lower.
Lower, sorry.
So there you see the realization. So we put a lot of attention in how we can really make the dike with what kind of material, what kind of control, and so on. So we can have a very high performance dike in lime-treated soil. So we had a stretch with lime-treated soil and a stretch with untreated soil to allow us some comparison. So we did overflow experiments on about 60 centimeters wide channel with some velocity measurements, erosion depth measurement as well, manual, and with the 3D laser scanner. And so we could have very interesting results that I will comment in the next slide. Please continue with this one. So no, that's okay. That's okay.
What was your request?
No, that's okay.
You want to continue?
That's okay. That's okay. I will continue. Thank you. So here are a few typical results of the overflow experiments. Thanks to the 3D laser scanner, we had a very accurate profile of the dike before the experiment, after each step of the experiment, and we could compare also with treated and non-treated soil. And we could come up with a very precise erosion volumes eroded and ratios and so on to compare how the non-treated and the treated soil are eroded. Next, please. We processed we processed all this information, and we could come up with design recommendations and optimizations thanks to lime treated soil. For example, how you can protect the inland or the riverside. Next. How you can deal with the beam that is defining your overflow level, for example, if you have a spillway. Next. How you can deal with the materials to be resistant against internal erosion. Next one. And also we had a very interesting insights about how lime treated soil behaves with burrowing animals. Next, please. And so we came up with cost estimates also for these two designs. Yeah, and so it was very interesting for us to go from this DigueELITE project to the Polder2C project, because the context is more or less similar, meaning that we have a play field to do some large scale tests, but the scope is much larger in Polder2C. We have more funding, more possibilities to do more experiments. What is very important is that we have now this internal collaboration and sharing experience, because our first project was only a French project. It includes new topics, so again, a wider scope. And next, please. And so it's a very good match with the ISL strategy with respect to R&D in its core business. So that's why we are very happy to collaborate in this project.
Thank you, Nicolas. I will take back the floor for last few minutes and show you one very different project, which is one of our case study currently, and more specifically related to structure that is already existing and we are repairing in the sea coastal area. I will just give you a few overview on the French regulation regarding dikes, because it has changed in 2016 and 15, sorry. And what is interesting is now, before we used to consider the dike one by one and to set up regulation for each dike, and on the same river you could have a part of the dike that is managed by for example, by a city with no much incomes and not much protection for the people there, and downstream you could have another part of the same dike that is managed by another city that has much more means to deal with it and better protection. But now we think a bit differently. We first look for protected area, and then we look for all the structure that is protecting the same area. So in the coastal parts, you can have protected area in the seafront, but you can consider into a full diking system, part of dikes that were already existing, also part of, for example, air dunes that you cannot control, but you can at least monitor and be aware that they are contributing into the protection for people there, and also part of river dikes that are also closing the area. And now you deal with this full view of a diking system, and that's interesting. I won't go much further, but just for you to know that in French regulation, for each diking system, you have to set up official levels that are designed or calculated by a certified engineering office like we are. And it's depending on the probability of breaching the dike, depending on the level of hydraulic loading on the dike. And more recently, the French regulation added the dike that are resistant to overflow, which was not existing before, meaning that we have a new way of thinking that the dikes may be able to resist to overflow, and then the official level can be higher because you consider that when the flow is going on it, then it's not ready to breach very soon. Just not in details, but just the difference between 2015 and since then in the duties for the waterboards is that you have to, for example, for start, you have to have a permit for your diking system, and the permits depend on the person you are protecting in the protected area. And then you have a rating of your diking system. Before it was on each dike, and now it's on the full diking system. And you consider people, inhabitants living into the protected area, but also people working there. And you have a lot of duties, like for example, you have to do in-depth inspection visits with different frequency and monitoring reports. And all this is depending on the number of persons that are protected by the diking system. And also something which can be interesting for you is that for sure, we have to design the structure by following the recommendation by the French code, but also all the manager of the diking system, they need to set up a risk management guidance or handbook. And this we are working with Bart and Marianne to share experience on the setting up this kind of risk management and emergency response handbooks. So more specific, I talk about the regulation, and you will understand a bit more why. So for the project I'm sharing with you, we are here on the northern part of France. That is a town that you may know, which is Calais, and is linked to England. So very well known for this tunnel. And we are more specifically here in the harbor of Calais. Here you have some rivers that are ending up in the harbor of Calais, and some basin. On the lower part here is marina, and on the upper part is just a basin that is storing floods coming from the continent and to be sent back to the sea. What is interesting to know is that beyond there, the ground is lower the sea level, just like you can find in some of your countries. So a lot of water to bring back to the sea. Here, the population that is protected by the structure in the harbor has been calculated, and there are quite a lot of people there. So the diking system that were allowed is rated B in the classes I showed you before. And it includes two parts, dike, first, that is separating the marina and the basin, and a tidal door. And these two parts are connected, and they are protecting people from floods coming from the sea. Here you see an overview of the area. So the marina, the harbor is on the top part of the picture. And then you see this storage basin that is keeping the water while the door is closed. What's happening is that the door is closed at high tide. So the water coming from the continent is stored temporarily in this storage basin. And when it's low tide, then the door opens and provides the opportunity to lower down the water level in the river. But you see the slope here is in a very bad shape, so need to be repaired, and it's mainly due to the high velocity that you can meet in the basin when the door is open. The door has different issues. Mostly is that the invert under the door, like it's two parts. It's the door is here, and then you have a safety mask. Back there. So here is the basin, and on the left side of the first picture there is the harbor. And since the invert is in a very bad shape, the groundwater flow is going under the invert and washing out the base ground, and then the door is submitted to internal erosion issue under the ground. So we did some calculation to provide repair measure to this structure. For the dike, it's quite easy. We have to soften the slope to increase the safety coefficient of the structure and to provide some protection for the two, since they are high velocity on the river or the basin part. But we have some issues nearby the door because the area is not so big. Then we cannot soften the slope. Then we have to repair the existing slope with grouting behind the existing protection and repair the two as well. We did some numerical calculation for this. For the door, is a bit more complicated. So we set up a 3D model of the door and with the ground parameters that allows us to see first the hydraulic flow under the door and also the mechanical behavior of the door itself and the ground around. The solution for this issue is to set a sheet piling on the arbor ports under the door in the invert of the door. And this allowed to increase the groundwater flow under the invert and then reduce the risk of internal erosion. So these are part of the drawing that we made to design the solution. So now we are finalizing the project design, and we will go through environmental study as well to finish the project itself, and finally we will start the tendering process and follow up the construction sites. So this is quite a regular project we can work on with some specific technical issue that is very interesting. And also what is interesting here is that we have to provide solutions for these two structures that are protecting people from flood coming from the sea, but as well protecting people to be able to release the water coming from the polders behind up to the sea. So it's in the climate change, how to say, in the climate change, due to climate change impact, and the performance of the systems needs to be as high as possible and to increase a bit. And that's it. I hope it was fast enough, so it's not too late.
No, very interesting presentation of ESL. Very, your organization is working much broader than I thought, and especially your examples of the harbor is really interesting. In fact, we needed much more time for it than we had, but my congratulations to you and Nicolas for this good performance, I think.
Thank you.
Anyone